During your journey while learning Nest.js, you may have encountered various different errors while working with the framework. In this lesson, we'll walk you through the most common issues engineers typically run into when working with Nest, showing you how you can solve and avoid them in your future applications. Let's start off by looking at the cannot resolve dependency error, which is probably the most common error message you'll see when working with the framework. The most common culprit of this error is not having a provider in the module's providers array. However, this is not always the case, and there are many other scenarios where you may stumble across this error. First, let's showcase the most evident scenario where our Coffees controller that we generated in the previous lesson depends on a Coffees service that is not registered in the module's providers array. So let's head over to our IDE and open up the Coffees module file and remove the Coffees service from the providers array. Let's make sure to save our changes, then open up our terminals again, and as we can see, the infamous cannot resolve dependency error showed up, of course. If you run across this error while developing your application, take a look at the module mentioned in the error message and look at its providers. For each provider in the providers array, make sure the module has access to all of the dependencies. Oftentimes, providers are duplicated in a feature module and a root module, which means Nest will try to instantiate the provider twice. Along with just manually verifying our dependencies are correct, we can set the nest_debug environment variable to a string that resolves as truthy and get extra logging information while Nest is resolving all the dependencies for our application. So let's terminate our process and add nest_debug equals true before the npm run start:\dev command just to turn this feature on and run everything again. The string in yellow found in our terminal is the host class of the dependency being injected. The string in blue is the name of the injected dependency or its injection token. And the string in purple is the module in which the dependency is being searched for. Using this method, you can usually trace back the dependency resolution to see what's happening and why you're getting dependency injection issues and errors. As we can see here, for our Coffees controller, Nest is trying to resolve the Coffees service dependency and it's sequentially searching for that dependency in the host module, which is the Coffees module. After looking there, it also searches within the imported modules. Since our Coffees module does not import other modules at this moment, it won't be able to find the Coffees service there as well. Interestingly enough, we do see an internal core module show up here, but we didn't even import that in our application anywhere. Well, the internal core module is actually an internal framework module that gets automatically imported into every module, providing us access to classes such as reflector, module ref, and many others that you may have seen before, a lot of which we covered in the fundamentals course. So, as Nest tried to search for Coffees service in all of those places, and it was not provided in any of these modules, Nest errored out with the can't resolve dependencies exception. Alright, so far, this was the most obvious scenario where you may have seen such an error plenty of times. Next up, let's dive into something a bit more complex. Before we continue onward, let's make sure we revert the change we did in the Coffees module file and add the Coffees service provider back in the array. Let's change gears slightly to showcase another similar and common situation developers frequently stumble upon. Let's start off by declaring a new interface in the Coffees service file and call it Coffees data source, placing it right above our Coffees service class. We'll use the index signature to describe the types of values that are possible here. In this case, we assume that the data source will be an array that consists of 0 to n elements, and those elements are of type coffee. As you can see in the comment above, we could alternately use the type declaration here if we wanted to. Now, let's try to inject this Coffees data source into our Coffees service. Let's save our changes, open up our terminals, and look at the error message we received this time. As we can see, instead of seeing a message that says something about our Coffees data source here, we only see object, which makes this error even more confusing and ambiguous. But why isn't Nest helping us out here? Well, the reason is actually because TypeScript doesn't leave any metadata about interfaces. Every interface is represented as object in the produced JS file. So we can't really provide users with helpful information about what's missing in the Coffees service provider here. but that's why we can't and shouldn't use interfaces as provider tokens. As a best practice instead, let's declare a new symbol above the interface declaration and name it coffees_data_source and use this instead. Now, let's use the inject annotation to inject that data source into our Coffees service. Let's save our changes and navigate to the Coffees module file. In here, let's declare a new Coffees data source provider using the custom provider syntax. If we save our changes again and check back in our terminal, we'll see that everything works now, no errors. So now, for fun, let's do a little experiment and move Coffees data source declaration to the Coffees module instead, removing it from the Coffees service. Let's also update our import paths as they will be different now. Let's save our changes and open up our terminals again. As we can see here, we're getting an error now. But what happened? Well, the reason why we're seeing an error now is that we just introduced a circular import in our application. Circular dependencies can arise when two providers depend on each other, or TypeScript files depend on each other, whether that's exported variables, constants, functions, etc. In our case here, we have the Coffees module importing the Coffees service so it can be registered as a provider, but at the same time, the Coffees data source is exported from the module file, being imported into the service, so it can be injected there as well, hence the circular import. In our exact case, the reasoning this is all happening is pretty straightforward, especially since we noticed the issue the moment we did it. However, in more sophisticated applications, tracking circular dependencies can be very tedious and generally difficult to uncover where they're actually coming from. Lucky for us, this is where the tool Madge comes in handy. Madge is a developer tool for generating a visual graph of your module dependencies, finding circular dependencies, and it even helps give us other useful information about everything. Let's open up another terminal window and execute the following command and point Madge to our built nest code in dist/main.js, passing in the circular flag. We can see here that Madge found one circular dependency for us. Fantastic. We can even generate a dependency graph using the following command, passing the --image flag and the name of the image we want to save it as. Note, if you want to generate a graph with the Graph Viz tool, you can find more information about that in the description below this video. Let's open up the graph we just created and see what we have in there. In the image shown here, we can see that the blue nodes have dependencies, green nodes have no dependencies, and red nodes have circular dependencies. As we can see, Madge really helps us visualize what depends on what in our applications. The Madge tool, along with the visualization tool, really help us pinpoint and locate circular dependencies, as well as other issues in our application quickly and effectively, letting us make some changes and give us the ability to test everything once again to see if we fixed whatever problem we're facing. In the case of our circular issue here, as a best practice, we should only ever export one thing from every file, but sometimes we would go against this practice. Let's say we had a constants TS file, where we were holding a bunch of constant variables. Ideally, we'd want to make sure ESLint is throwing a linting error at us whenever we forget this to prevent situations like this from arising in the future. If we move the const export into its own file, containing that new interface we made, and make sure to update our imports, we'll see that our application now runs without any errors, and if we run Madge again, we'll see there are no longer any circular dependency errors as well. Following this best practice in the future will prevent these situations from arising in your Nest applications.